Hello everyone, welcome to another lecture of the course Digital Signal Processing. In the previous lectures, we have seen what is known as Z transform. We have seen what is region of convergence. We have also seen the properties of region of convergence and solved some examples of how to find the Z transform of any discrete time signal. Therefore, from this we know that the Z transform of any discrete time signal x of n can be calculated using the formula summation n running from minus infinity to infinity x of n into z to the power minus n, and let the region of convergence for this x of n be R. Now this formula allows us to transform from time domain to Z domain. But what if we are given the expression of Z transform and want to come back to time domain? This is achieved by what we call as the inverse Z transform. The equation of inverse Z transform is given as x of n is equal to 1 upon 2 pi j integral over a contour c x of z into z to the power n minus 1 dz. Now if we look at this equation, we can see that it is very difficult to solve this every time in order to find the inverse Z transform. So generally inverse Z is found by mere observation, and there are various ways in which inverse Z can be found. And in this course we will look at two such methods. The first one is using partial fractions. And the second one is using the power series and long division. Let's start with partial fractions method. In partial fractions, the Z transform equation x of z is decomposed into its partial fractions components. And each such component is then, and the inverse Z of each such component is found by mere observation. And for this we require the knowledge of some basic time domain Z transform pairs which we had already seen in previous lectures. For example, the first one which we had seen was of the form a to the power n into u of n, whose Z transform was obtained as z upon z minus a with a region of convergence mod of z greater than a. The second form we have seen was minus of a to the power n into u of minus n minus 1, whose Z transform was obtained as z upon z minus a with a region of convergence of mod of z less than a. Now third thing which we need to know is the Z transform of a constant multiplied with unit impulse. Let us try finding the Z transform of this. Therefore we have x of z is equal to summation n running from minus infinity to infinity a into del of n into z to the power minus n. Now by the sifting property of unit impulse, if any signal y of n is multiplied by unit impulse placed at n equal to n naught, then this signal picks up the value at n equal to n naught, that is y of n naught, scaled by the impulse n minus n naught. Therefore, in this case, this n takes the value 0, and therefore this summation reduces as, let's take out this constant. So we have summation n running from minus infinity to infinity del of n, and z to the power minus 0 is nothing but 1. And we also know that this summation n running from minus infinity to infinity, del of n is nothing but equal to 1. Therefore, the value of z transform is this constant a. Therefore, the z transform of unit impulse scaled by a constant a is given by the constant a itself with a region of convergence of entire z plane. In the subsequent lecture, we will see an example of how to find inverse z transform using this partial fractions method. And we will also see how to find the inverse z transform using the second method, which is using power series. But before that, let us revise what we have seen in this lecture. We have seen that the inverse z transform equation is given as x of n is equal to 1 upon 2 pi j integral over a contour c x of z into z to the power n minus 1 dz. And there are various methods of finding this inverse z transform by mere observation, and in this course we will look at two such methods. The first one is the partial fractions and second one is by the power series. Let's stop here. Thank you.